here's your periodic table. All right, one of the things I want to make sure we mention, the horizontal rows. Those are called periods. All right, the horizontal rows are called periods. So we start at the very top. We have period 1, period 2, period 3, 4, 5, 6, 7. So we have 7 periods. The verticals are called groups. We have 18 groups. So the rows are periods, and the columns are called groups. All right, so we actually have a lot to write up here. This is where we're going to spend a lot of time before we actually get into anything. Okay. Let's have the back of this. So I want to make sure we talk about how we break down the periodic table. So we already said the number of protons is the atomic number, right? All right, so if I look at sulfur, so right here is sulfur. You guys look at your periodic table. What's the number of protons for sulfur? What do you guys say? 16. So I have 16 protons. I should have how many electrons? 16. That's not hard. Which period is sulfur in? Third period. Which group?
16.
Group 16. What's the charge of sulfur? What's the charge of sulfur? Because this is really kind of important here. This is the most important feature you're ever going to get out of the periodic table. Right? Now, I know we have a lot of different freshmen here as well. I know last year in middle school you guys spent a lot of time memorizing the periodic table. I apologize for that. I hope you guys never do that again. It's kind of pointless to memorize the periodic table. My concern is that you know how to use the periodic table. And that's what we're going to talk about today. But in order to talk about that, I want to go back to the lithium, beryllium. Let's talk about magnesium. Notice that magnesium had 2 extra electrons in the outer shell. 2 extras. And we have extras. What would be like a math symbol that we would use for extras? Plus. If you're short, okay, not short in height, but if you're short, like I'm short 3 electrons, how would you represent that? -3. All right. So basically, everything in group 2 has 2 extra electrons. So therefore, we call that a charge of +2. Everything in group 1, has 1 extra electron. And then we're going to skip the middle, called the transitional elements. They don't play by the rules. So we're going to skip those. We're going to go all the way over here to boron. Boring boron. Everything here has 3 extra electrons. Okay, we got that? Okay. By the way, where are all the metals at on the periodic table? Where's right there? Not so much the center. Your strongest metals are all the way over here on the left. The farther left you go on the periodic table, the more metallic that you become. So what happens when you go to the right? You become less metallic. You actually become so unmetallic, you become what in the far right column? Gas. These are your noble gases. Okay? They actually, why are they called noble?
Because they don't mix well with others.
Yeah, they really don't. They think of themselves better than everybody else. These are the only elements that actually have full outer shells automatically. And therefore they're called, sometimes they're called inert. Inert, which basically means they don't react. We're going to see a video about that tomorrow. This will just be a short clip. So we're going to go over here to group 17. All of these are -1. They're short 1 electron. And then oxygen is short 2 electrons. Nitrogen's column has -3 electrons. And then carbon is stuck right in the middle. Carbon could go either way, plus or minus 4. So this is kind of where we get close to bonding. Remember we talked about table salt? What was the compound for table salt? NaCl. Take a look at this. Na, what's the charge for sodium? +1. What's the charge for chlorine? -1. What's +1 minus 1? We balance out. So what all these elements are going to do in the natural world, they're all floating around together, and they're desperately trying to make combinations that balance out to 0, so that everybody's reached their equilibrium. We have no charges. That's what they're trying to do. Magnesium is trying to get rid of those 2 electrons as fast as it can. In fact, tell me what's easier. Is it easier to get rid of 1 electron or easier to get rid of 3? It's easier to get rid of 1, isn't it? These metals are highly reactive. In fact, sodium actually bursts into flame in contact with water. It's a metal, and yet it bursts into flame with water.
That's awesome.
Totally awesome.
Have you seen it? Have you seen it?
Yes. Sodium is actually so soft you can cut it with a butter knife. It's almost like cutting through clay. Really weird. On the other side of this, the halogens are extremely reactive as well. For the same reason. Is it easier to find 1 electron or to find 3 electrons? It's easier to find 1. So they bond very quickly. That's why we call them reactive. They're highly reactive because they just readily bond it anywhere they can fill the hole. That's basically what they're trying to do. Please, somebody, come plug my hole. That's basically what they're doing here. Yes, I said that. Okay, so that's basically the periodic table. Guys, I'm expecting that you guys know how to use, and hopefully you guys wrote down these numbers, because that's going to be really important later on in this unit. Okay? So, let's actually, somebody pick, don't be crazy here, but somebody pick an element. Oh, better be a good one. Not something crazy.
Iodine.
Iodine. Yes, we can do iodine. Wonderfully. All right, so we're going to do iodine, guys. So we're going to be looking at this one right here. All right, so looking at iodine. We're going to fill in this information here. Oh, it says sodium. We'll come back to do sodium. So let's do iodine. All right. So, guys, everybody find iodine on your periodic table. All right, this is basically what your homework is going to be. You got to tell me some basic information. Michaela, what is the atomic number of iodine? 53. Well done. Beth, what is my atomic mass of iodine?
127.
127. Excellent. All right, so based on those two, we can figure out the next three. So, Lorana, number of protons?
Don't you subtract the mass and the
Nope. Protons is the same as the atomic number. 53. So, CJ, if the number of protons is 53, what's the number of electrons? Are the protons and electrons supposed to be the same?
What?
Are protons and electrons supposed to be the same?
Yeah.
Yep, so this should be 53. Alright, now the tough one. Mary, how do I find the number of neutrons?
Subtract 53 from 127.
And what do I get?
74.
74 neutrons. Okay, do we get that? Take the mass minus the number, and we have the number of neutrons. Okay? Alright, so let's do that again for sodium. Alright, so now this time we're going to do sodium. I'll do it in pink.
Yeah.
Alright, so for sodium, Courtney, what's my atomic number of sodium? I'll give you a hint, it's a metal. It's a very reactive metal. Very good, it's 11. Harry, what's my atomic mass for sodium?
22 or 23.
23. Gabby Ball, what's the number of protons?
23.
No. Our protons are the same as your atomic number.
Oh, 11.
11. Ivan, what's the number of electrons?
11.
11. Okay. Dakota, what's my number of neutrons?
12.
12. Got this? All right, tomorrow we're going to go into more detail on this, but I think this is a good place to stop today. I don't think there's any more we need to go over tonight. Tomorrow. By the way, guys, I think you might appreciate this page. That is the overall disbursement of elements throughout the world. Not the universe, just our planet.
I just want you to know that the hallways are exactly the same.
Are they? Sure looks
Mrs.
different.
Baker counted it all.